Hi guys, so in this video we're gonna be talking about primer, calculations, okay, let's say that you've been working on a gene called DKC, for example, okay, DKC1. That DKC1, for example, has 15 exons, and then you want to PCR amplify this gene for further studies such as mutations or whatever you want to study. And for that, you're gonna have to have primers, right? Because if you want to study exons, well, you want to amplify or pinpoint that specific parts of those DNA with primers. So primers are pretty important, right? Okay, so well, you design primers, and then your professor kindly orders your primers, and then you all of a sudden receive your primer. Once you receive your primers, let me zoom this out a little bit. Okay, primers. Okay. Once you receive that, notice that you're expecting to see something like this. Or maybe the cap is like, black or something. Some sort of tube that looks like this, specifically like this point, you're gonna see it. Once you, for example, you see primer for the first time, you're definitely gonna see this this end point of it. Anyways, this primer will have some information, as you guys would expect. It will have some info such as name, TM, which is the melting temperature, and some information about the sequence, some A's and C's and T's and G's. And of course, you know that primers are gonna be, first of all, when you design your primers, you're gonna be designing in pairs, like reverse versus forward. Okay, for example, it's gonna tell you, oh, it's a reverse or forward primer and all of that stuff. And most importantly, for the sake of the calculations, it's going to tell you some concentration, most probably in nanomoles. Let's say this is a specific one that I got from this company. It's 40.1 nanomoles. Well, it's in general for each means 1. For 1 nanomole, okay, primer, add 10 microliters of water. DI water, sorry guys, here. Just, whatever is required in your lab. Maybe nanopure water or DI water or whatever. But just remember, for each nanomolar, add 10 microliters of water. Okay? Well, how about if you have a primer that is 40.1 nanomolar? How much water you're going to have to add? More specifically, let me zoom this out a little bit. Recall math, if 1 equals 10, 40.1 equals what? Cross multiplication. Let me change this question mark to x. X equals 1 goes in the bottom. It's in the denominator. 40.1 times 10. And 40.1 is in microliters. It's in nanomole. And obviously 1 is in nanomole also. These cancel out, the units cancel out, and 10 is in microliters, right? Because it says for each nanomolar primer, add 10 microliters of water. And so you cancel these together and you end up with your microliters, right? And 40.1 times 10 is basically moving this decimal to the right, and it's 401 microliters of water. Notice what you did here, all of these things that we were talking about. I'm just gonna zoom this out, or maybe the next page. Whatever you've been doing here up to here, all you've been doing here, you've been making a stock solution. Notice once you got this tube that I just drew, and it has like all these informations and stuff like that, you need to add water to this. And the reason is because once these primers arrive, they are to be they're known to be lyophilized. Yeah, I mean it's really hard to pronounce this for me, but it's lyophilized, meaning it doesn't have water. It basically it doesn't contain any sort of water. Water is basically removed. Oh. Basically means that water is removed from this. So you're going to have to add water. The calculation that we did, 40.1 nanomoles times 10, and we figured out that, oh, okay, we're going to have to add 401 microliters. Microliters. So obviously for this microliters, you're going to have to use 1,000 microliter pipettor. Okay, so once you add this 401 milliliters, after that, let me zoom this out. This is step one. Step one. After that, after you added, for example, 401 microliters, you're gonna have to spin, not so much, okay, not for too long. You just want to spin for 10 seconds maybe, until everything is well incorporated, like DNA and the water are well incorporated. Obviously, you don't want to spin or vortex for long because you don't want to cause damage to the DNA and all of that stuff. Well, after you added that water, you have made a 100 micromolar stock solution. Another way that they say this, they also call this 100x. Okay? So this is very, very, very important. So you have made a 100 micromolar stock solution. Okay? For the next step, which I'm gonna call 3, you want to make working concentration. First of all, I forgot to mention in the last page, once you added that 401 microliters of water, you're gonna spin obviously. After that, you're gonna take half of it, like 401 divided by 2 is 200.5 microliters. You're gonna add that to a new tube, clean tube, okay? And then you're gonna put all of the information on the tube. You're gonna store, plus you're gonna obviously initial and stuff like that, and you're gonna put it in -80 freezer. Just keep it so that, oh, okay, half of it is safe in -80 freezer. With the other half, which you're basically gonna have to leave in the tube that company sent for you, what you're gonna have to do, you're gonna have to use that. You're gonna have to dilute that furthermore to working concentration. And working concentration is 5 micromolar. Remember, initially you made 100 micromolar. After you added that amount of water that I said, that was 100 micromolar. Now you need to make this into 5 micromolar. Well, if you divide 100 by 5, you're going to get 20. So that means that your working concentration will be 20 times more diluted than the stock solution. And then you're going to have to use this as follows. You're going to have to do a 120 dilution. 120 dilution is basically saying 1 over 20. But 1 over 20 is basically 1 over 1 plus 19. This is water. And this is your 100 micromolar stock solution. So what I mean is that from that 100 micromolar tube, you're going to take 1 microliters primers plus 19 microliters of DiH2O, mix them together, so at the end your total volume is 20. Okay? 1 plus 19 equals 20 microliters. I hope this helped you guys. Let me know if you guys have further questions or if something is not making sense. I hope you guys enjoyed this video. Don't forget that, once you get those primers, those are lyophilized. They don't have water, so you add water to make 100 micromolar primers. After that, basically whatever you made, that 100 eggs is basically your stock solution. After that, you want to do it as working concentration. So let's say if you want to do 20 microliters, you just want to have 1 microliters of primers and 19 microliters of water. Okay, you add them together. The total has to be 20, not 21. 1 to 20 ratio is not going to add up to 21. It's just going to be 1 plus 19. And then let's say, how about if you want to do 4 microliters? Well, you're going to have to time 1 by 4. Like, for example, 1 times 4 microliters and 10 times 4, it's going to be 4 to 40. Well, obviously, 40 is going to be the total at the end. So 4 microliters of it is going to be your primer, and 36 is going to be your water. I hope you enjoyed this. Let me know if you guys have further questions. Have a great day.